Alrighty, we are continuing our study of quadratics. All of last chapter was about quadratics, graphing them. What is the y-intercept? What are the zeros? All that kind of stuff. But we really were not solving quadratic equations. We were just graphing quadratic functions. This chapter is mostly about solving quadratic equations. At the beginning of the chapter, the only method that we had to solve quadratics was by graphing, but that resulted in you needing to have Desmos or know how to use a graphing calculator. But it worked really, really nicely. It wasn't too hard. Then we got into how to factor a quadratic. And then with that, we learned how to solve by factoring. We're now learning a different way to solve a quadratic with some special cases. So this is 7.5. The start thinking part says, how are the following quadratics the same and how are they different? And what does that tell you about the graph? So when you're looking at this, you have your two different equations. The main thing that you guys should have noticed was that one has a b term and the other does not have a b term. They're both quadratics, so they're both going to look like a u, a parabola. It looks like they both are going to open up. They both have the 2 for the coefficient in front of the x squared, so that tells you something about what your parabola looks like. But the main difference here is that one has a b term and one does not have a b term. And the one that does not have a b term, we know is not going to be shifted left or right. So equation B is not going to be shifted left or right, whereas equation A will be shifted left or right. And we could use the formula for the axis of symmetry if we wanted to find out which direction and by how much. Now, solving by graphing. It says, using what you noticed above and your understanding of solving by graphing, what do you know about the solutions to the first equation versus the second? Well, the first equation will be shifted left or right. The second one will not be shifted left or right. So what you're going to know about that second equation, if it's not shifted left or right, whatever one of the solutions is in the positives, there's going to be one that is exactly the same in the negatives. No b term, not shifted left or right. If you have one solution of 5, you're going to have a negative 5. A 2, there's going to be a negative 2. There's always going to be opposites, which are your solutions. For equation A, since it has been shifted left or right, if you have one solution of, let's say, 1, that does not mean you're going to have a solution of negative 1 as well. You're not going to have opposites for your solutions. Equation B is a lot like what we are going to be doing today. It is going to be special cases where there is no b term, and then there's just one other kind of special case where you can use this as well. But when you're looking at this, it says solve a quadratic without a b term. So if you had this quadratic, x squared equals 36, you could go over and graph this. You could graph it and get a parabola and then see where it intersects the horizontal line at 36. You could go over and get the 36 on the left-hand side. You would have x squared minus 36, which you would graph and see what the x-intercepts are, because then you would be seeing where it intersects the x-axis to find your solutions. We're not going to do that. You also could have solved this by factoring as well. But we're not going to do that. I would just kind of want you guessing and checking. What are the values of a number that can be squared that would get you 36? Everybody pretty quickly was able to get that it must be 6. 6 times 6 does get you 36. Now, what some of the students forgot is that you would also have a negative 6 there. So you'd have 6 and you would have negative 6. This should make sense when we're talking about solving by graphing because there is no b term. So if it's not going to be shifted left or right, so if there is a 6 as a solution, there must be a negative 6 as well because it is symmetric about the y-axis. The next one on here, if you're saying 3 times some number squared equals 300, what is that number? Well, we know it's going to be, for guessing and checking, 10 works. 10 squared is 100, and 100 times 3 is 300. But then you also have a negative 10. Negative 10 times negative 10 is 100, and 100 times 3 is 300. So that also works. And this should make sense because if you get the 300 to the other side and you graph this, there is no b term. It is not going to be shifted left or right. So it's going to be symmetric. And whatever you have for a solution on the right, you will have a opposite solution on the left. That only makes sense if you have a parabola that is symmetric about the y-axis because it's not shifted left or right. You're going to have opposites that are solutions. And now on this next one right here, you're trying to figure out a number where when you add 1 to it and then square it, you're going to get 16. We now know that number must be 4. 4 squared gets you 16. So what is x that would result in that being 4? Well, 3 works because 3 plus 1 equals 4, and 4 squared is 16. But then you got to get kind of clever. On this one, Negative 5 plus 1 is negative 4, and negative 4 times negative 4 also gets you 16. So this is going to have the two solutions of 3 and negative 5. This should make sense when you're thinking about solving by graphing. This, if you go over and actually FOILed the x plus 1 and the x plus 1 and then got the 16 over, it would have a b term, meaning it has shifted left or right. And if it is shifted left or right, then you're not going to have opposites that are solutions. But the main thing I wanted people to do on 1, 2, and 3 was just kind of guess and check and figure out values that would make these true. Now we have this application here. The application is you have a garden that is a square. We don't know what the lengths are. It's something by something. You have this part of that garden that's just missing that we're not going to account for, but then you have this separate garden on the side, which is a veggie garden. It's a 5 by 2. We know all of it together gets you 53 when you take away that part that is no garden in this portion. And students were supposed to figure out what are the dimensions of the main garden. So when you think about this, the main garden is going to be an x by x, so we can call that an x squared. Then you have the part that does not exist, which is a 3 by 2, so we're going to have to subtract that. That gets you minus 6. And then we have to add that veggie garden, which is a 5 by 2, which is 10, and it's going to equal the 53. So you have x squared minus 6 plus 10 equals 53. And when you get that x squared by itself, by going over and combining the 10 and the negative 6 and then getting rid of it on that side, you know that you're going to have x squared equals 49. And you can think of what are the values that would make this true. And it's technically 7 and negative 7, but for this problem, negative 7 makes no sense. It's called an extraneous solution because you can't have a side length of negative 7, so we just ignore that solution even though it's technically a solution. And you find out that this maiden garden is going to be a 7 by 7. And you can always check your answers. 7 times 7 minus 6 plus 10, and you do get 53. Now, when we look at this is just a basic linear equation that we're trying to solve. We have this algebraic method of solving this. In this case, you would add 5 and add 5. That is called the addition property of equality. You're adding on both sides. And the reason we're doing that is because subtraction and addition are inverse operations. So that is how you got rid of that minus 5, was doing the inverse operation. Next, you have to get rid of the 4, and you divide by 4. And the reason you do that is because division and multiplication are inverse operations, and they undo one another. And you get to the point where you have 12.5. Let me make sure that's correct. 50 divided by 4 is 12.5. Yeah, that's right. So my point here is that we know that there are inverse operations. Adding and subtracting are inverses. Multiplying and dividing are inverses. So what we're going to move on to is, rather than guessing and checking when we solve the x squared, like to try to get rid of the x squared, there is an inverse of squaring. So if we're trying to solve this right here, the first thing you would want to do is you would subtract 1 from both sides, and you get to 5x squared equals 180. That is inverses. Adding and subtracting are inverses. Then you get rid of the 5 by dividing, because multiplication and division are inverses, and you get to x squared equals 36. So what we needed to know is, what is the inverse? What undoes squaring? And the answer is square rooting. So on here, you would go over and square root the x squared to get it just to be an x. And when you square root 36, you got to be very careful, because that's asking what number times itself gets you 36. And 6 is correct, but negative 6 is also correct. So people always forget the minus here. So it is x equals plus or minus 6. And like we said, with the graph, this makes sense. No b term. So when you solve by graphing, you would have opposites that were your solutions. So when you solve by square rooting, do not forget you have to have a plus or minus. Like we saw in the garden problem, sometimes the minus just doesn't make sense for the problem, but it is still a solution. After this, the students tried these problems. On this first one, when you add 5 to both sides, you get 1/2 x squared equals 8. And when you multiply by 2 on both sides, you get 16. And then to get rid of the x squared, you square root and square root, and do not forget the plus or minus. This makes sense. No b term. It would be symmetric about the y-axis. You would have 4 and negative 4 as your x-intercepts. The next one, when we get the x squared by itself and you subtract 20 from both sides, you get negative 25. You square root. You can be very tempted to either say 5 or negative 5. But that's not true. This is asking what number times itself gets you negative 25. Well, is it 5 and 5? No, that gets you positive 25. Is it negative 5 and negative 5? No, that also gets you a positive 25. So technically, this has no real solutions. You talk about imaginary solutions in Algebra 2, but for right now, this is no real solutions. And this should make sense. If you tried to solve by graphing, there would just be no x-intercepts when you ended up solving by graphing. Now this next one, you are going to add 10 to both sides, divide by 2, and then square root. Now technically you could put in your calculator the square root of 20 and get plus or minus 4.5 about, but that's rounding. Square root of 20 is an exact answer. Just like you might have 7/3 and you want to keep it exact, you don't want to do 7 divided by 3 and get a decimal, and you end up getting, what is that, 2 1/3. You can pull stuff out of a fraction, and you could also pull stuff out of a radical. So when you have rad 20, the way that you can go over and simplify this radical is you start dividing by your prime numbers. First 2, then 3, then 5, then 7. Just divide by your prime numbers till you can't divide anymore. So 20 is 2 times 10. 10 is 2 times 5. 5 is not 2 times something. It's not the next prime, which is 3 times something. The next prime is 5, and it is divisible by 5, so it's 5 times 1. You should have learned this in 8th grade math. Now, since you have double 2's, that releases 1 2 from in the radical. So it is 2 outside the radical, and 5 is stuck on the inside. Any doubles release a single one of those numbers to the outside of the radical, and any singles multiply together to be the inside. So technically, the exact answer is plus or minus 2 rad 5, and that's the exact answer. You should have learned this in algebra, in 8th grade math. Now, this last type of problem here, when we look at this and you have x plus 3 squared minus 1 equals 8, it says if you solve by graphing, would the parabola be symmetric about the y-axis? It would not. If you went over and FOILed that and then got the 8 away from that side by subtracting 8, you would have a b term. And since there's a b term, it is going to be shifted. You also know that the axis of symmetry is x equals -3. So that means that it has been shifted to the left by 3 units, and the answers are not going to be opposites. So no, they're not going to be opposite answers. So you could still solve this by square rooting, but it's going to be a little weird. So let's look at this problem. On here, you still are trying to get whatever is being squared by itself. So we add 1 to both sides, you get 16. Now to get rid of the squared, you ignore the x plus 3 on the inside. That is locked inside of something squared. So we got to get rid of this something squared first. So you square root and square root, and you have to be very careful. Do not forget, it is plus or minus 4. So now on the left, you still have your x plus 3, and it equals plus or minus 4. Now we want to get that x by itself, so we subtract 3 from both sides, and you end up getting -3 plus 4 and -3 minus 4. That is just going to be your two solutions. You do -3 plus 4 once to get one solution. You do -3 minus 4 once, and you get the other solution. And you find out your solutions are 1 and -7. If you solved by graphing, you can see what the graph would look like here. So this is a case where you can still solve by square rooting, even though technically there would be a b term. It's because it's given to you in vertex form. So the main thing here is if you are ever given something that is in vertex form or without a b term, do not solve by factoring. Do not solve by graphing, even though you could. Solve by square rooting. It's way quicker as long as you remember your plus or minus. Let's go ahead and crank through the homework here. On number 1, it says, which of the following quadratic equations will have solutions that will be opposites of one another? They're basically saying, which one of these don't have b terms? Or technically, it's a b of 0. So A and C both have no visible b term, which means you would have a 0x in there, and it is not shifted left or right, and therefore it is going to have answers that are opposites. B and D do have something that is going to shift it left or right, so therefore they're not going to have opposites. The next one says the equation x squared plus 100 equals 0. Will it have no solutions if you solve this by square rooting? What does that look like with graphing? Well, we know this has a y-intercept of 100. It is not shifted left or right, and it looks like the parent function. There's a graph of it right there, the basic graph. Does that thing have any x-intercepts? It does not, so that would have no solutions. So since it is in equals 0 form, x-intercepts are your solutions, and there are no x-intercepts. On these ones, you would want to solve these. So first, on the first one, you add 1, you get 75. Divide by 3, you get 25. And when you square 25, don't forget the plus or minus. You get x equals plus or minus 5. You could have solved that by graphing or factoring, but it's way better this way. It's quicker. The next one, you add 10, you get 280. Then you are going to divide by 7 and then square root. And that would get you approximately plus or minus 6.3. But using our method of simplifying radicals, divide by 2 till 2 doesn't work. So it's 2 times 20, 20 is 2 times 10, 10 is 2 times 5. 5 is not divisible by 2, nor 3, so we go to 5. It's 5 times 1. And this comes out to be plus or minus 2 rad 10. That is the exact answer. And then on this last one, you would subtract 3 from both sides, getting 36. Do not try to add 2 yet. It's locked inside of a squared. That's technically not a minus 2. It's a minus 2 after it's been squared and a little wonky. So we square it, you get plus or minus 6. So you have x minus 2 equals plus or minus 6. You add 2 to both sides, and you do 2 plus 6 and 2 minus 6. And that's how you get your answer of 8 and negative 4. This one right here is saying, hey, we've talked about this before. If you get everything to one side versus getting it to the other, you get 2 different parabolas. If you have 2 different parabolas, how could they have the same solutions when you graph? One opens up and one opens down. Well, all it is that even though one opens up and one opens down, they have the same x-intercepts. So that is why they would have the same exact solutions. And then the last one just is trying to remind you guys how to solve by factoring, get a little extra practice. You have to get one side equal to 0. After you get it equal to 0, you get your ACB chart. So you end up getting negative 30 and negative 7. That's negative 10 and 3. You either do the box method or some other method, and you end up getting x minus 5 and 2x plus 3. They are being multiplied together to get 0, so either one of them is 0 or the other. And when you solve that, you end up getting 5 and negative 3 over 2. Why didn't you just solve this by square rooting? Well, you can't. There's a b term. It is not an equation without a b term or in vertex form. Those are the only 2 cases. So to wrap this up, if you have an equation that has no b term, or it is already in vertex form, you can solve by square rooting. The main thing people are going to forget is when you solve by square rooting, you need to remember the plus or minus. Hope that made sense. Thanks for watching.